Hello everyone, welcome back to Tech World with Sahana. Today I'm back with another chapter in our Kubernetes Zero to Interview Hero series. In this video, we are going to learn about how do we implement sensitive and non-sensitive data, which is our Kubernetes chapter 8, config maps and secrets. If you haven't watched from chapter 1 till chapter 7, make sure to check them out. I will mention the links in the description and I'll also pin them to the comments. So, without any further ado, let's get started. This is a list of all the topics that we are going to cover today. Let's start with our first topic, config map. A config map in Kubernetes is like a settings file for your application stored outside your container. Instead of hard coding values like app environment, log level into your code or Docker image, you store them in a config map. The key idea here is that config maps lets you separate your application setup from its actual code. You can tweak configurations anytime without rebuilding your Docker image. Just remember they are meant for non-sensitive data. Anything secret should go into secret instead, which we will study later in this chapter. Config maps are also flexible. You can plug them in as environment variables or mount them as files. Think of it like a remote control for your application. You are not changing the TV itself, just adjusting how it behaves. Let's check out different ways we can create config map. The first one is with the YAML file. So this is our YAML structure. The main thing here is the data section. That's where you actually define your application's configuration in simple key value pairs. Each key represents a config variable your application can read, and the value is always treated as a string, no matter what you put in there. The rest of the YAML is standard. API version and kind tells Kubernetes what resource you are creating, and metadata name just gives your config map a unique name so you can reference it later. Next, let's understand how we can create a config map from the existing file. Suppose you have a config.properties file. Here, the key idea is that Kubernetes takes your file and automatically turns each line into a key value pair inside the config map. So, whatever you have in the file becomes a part of your configuration. It's a super easy way to move existing config files straight into Kubernetes without rewriting them in YAML. And you will implement with these commands. This command takes your existing .properties file and turns it into a config map named myappconfig. Kubernetes reads the file and stores each line as key value pair inside the config map. Running this second command with -o YAML simply shows you the full YAML output. So you can see exactly how Kubernetes stored your configuration. It's a great way to verify that your config map was created correctly. Next, let's create the config map from literal values. These are the commands for that. This method is the fastest way to spin up a config map right from your terminal. No YAML is needed. You just pass your key value pairs directly in the command, and Kubernetes creates the config map instantly. It's a perfect for quick test or small setups where you don't need a full YAML file yet. And again, the second command with -o YAML simply shows you the full YAML output. Now, let's note down some important points that you need to remember. The first one is string only. All config map values are strings. If your application expects numbers or booleans, convert them in code. Number two is case sensitive. Keys are case sensitive, like capital letter app environment is not the same as small letter app environment. Number three is update. Updating a config map does not automatically reload pods using it. Use volume mounts for auto update or just restart pods after changes. Number 4 is avoid sensitive data. Don't put passwords or any other sensitive data here. We will use secrets for that. Now let's move with environment variables from ConfigMap. Environment variables let your containerized application read configuration directly from the environment instead of hard coding it. Connecting a config map to environment variables make your application more flexible and dynamic. It lets you update configurations without rebuilding the Docker image. This method is also most common way to use config maps for applications that rely on environment variables. First, let's understand the basic environment injection. Inside your pod YAML, this section means this environment variable values does not come from the pod itself. It's pulled from a config map. So here's what happens step by step. Kubernetes looks for a config map named myappconfig, which we discussed in the previous section. Let's take this config map YAML for example. Inside that config map, it looks for a key called app environment or log level for the second one. The value stored under the key becomes the value of the corresponding environment variables, app environment or log level, inside the container. That means this pod depends on another YAML file, the config map YAML. So, this name myappconfig is the config map name your pod refers to. App environment and log level are the keys inside that config map, and production and info are the values that will appear as environment variables into your container. In short, your pod YAML defines what environment variables to use, and your config map YAML defines where their values come from. Next, let's understand how to inject all keys from a config map. So we use this in case we want to inject all keys from the config map YAML. Inside your pod YAML, this particular section means this container isn't pulling just one key. It's taking all the keys from the config map mentioned. Let's take this config map file as an example. So here how it works. Kubernetes looks for a config map named myappconfig. It reads every key inside that config map. Each of those keys automatically becomes an environment variable inside the container with its values taken directly from the config map. That means this pod is also using another file, the config map YAML. So here the name myappconfig is the config map that is being referenced. App environment, log level, and timeout are the keys inside the config map. Production, info, and this 30 are their values. So all of these keys and the values together become environment variables inside the container automatically. You don't define them one by one. Moving on with our next topic, volume mounts from config map. We are taking the idea of config maps and using them in a different way, as files inside the container. Normally, we can pass configuration values as environment variables, but some applications don't read from environment variables. They expect configurations files instead. So Kubernetes gives us a way to handle that. We can mount a config map as a volume. When we do this, each key in the config map becomes a file, and the value of that key becomes the content of the file. This means if your config map has a key called app environment, Kubernetes will create a file named app environment inside your container with the corresponding data in it. Your application can then read that file just like it would on a regular server. So now the question is, why use volume mounts? Some applications, especially older ones, are built to read configuration from files like .yaml, .environment, or .properties instead of environment variables. For these kind of apps, Mounting config maps as volumes makes configuration seamless. By using volume mounts, you are letting your app use configuration files directly without having to rewrite code or change how it reads settings. The best part is that if the config map is updated, those changes automatically reflect inside the pods files. No need to rebuild or redeploy the container. In short, volume mounts let you manage application configuration as files, keeping things flexible, simple, and always up to date. So now let's understand how to mount config map as a volume. Inside your pod YAML, this part tells Kubernetes that this volume's data will come from a config map named myAppConfig. Then inside the container section, this part says where that config map data should appear inside the container. Here's it's at etc config. And here's how it works step by step. Kubernetes looks for a config map called myAppConfig. Every key inside that config maps becomes a file inside etc config. So the file name is the config map key and the file content is the value of that key. So if your config map looks like this, then inside the container you will see two files under etc config, app environment and log level. And files would contain the value, production and info respectively. This way the app can simply read configs as files, no environment variables needed, just a direct file-based configuration. Now let's understand how do we mount specific keys only. So inside your pod YAML, this part tells Kubernetes to mount only one specific key, that is app environment, from the config map, not the whole thing. And here's how it works step by step. This name myAppConfig is the config map that it needs to read from. Under items, the key field app environment points to the exact entry inside that config map. And the path environment.txt defines what the files should be called inside that container. Then in the container section, this part decides where this selected data should appear. Here it's at etc config. So the Kubernetes takes only the app environment key from the config map and writes its value into the file name environment.txt under etc config and contains the value production. Only this particular key is mounted, keeping the container's config clean and limited to what the app actually needs. Moving on with our next topic, secret creation. A secret in Kubernetes is a way to store sensitive information like password, API keys, or tokens. Unlike config maps, secrets are base 64 encoded, not encrypted by default. They allow secure injection into pods as environment variables or files. It also helps you avoid hard coding sensitive data into your images or code. So why do we use secrets? It keeps your sensitive data out of your Docker images. You can also rotate credentials without rebuilding pods. It also integrates with RBAC so only authorized users or pods can access them. First, let's understand basic secret creation. This secret YAML creates a basic opaque secret, which is the standard way to store arbitrary sensitive values. Inside it, this type opaque tells Kubernetes that this secret holds general key value data. Nothing special, just custom field you define. Then this section holds the actual secret values, but they must be base 64 encoded. So before putting them here, you encode them yourself with this command, echo-n your password pipe and then base 64, and it gives you the base 64 encoded format. Kubernetes stores these encoded strings, but when a pod uses this secret, Kubernetes automatically decodes them back to the original values. So the DB password holds the encoded version of your real password and the API key holds the encoded version of your actual API key. And the secret object safely holds these values until they are consumed by the pod. Next, let's understand secret creation from literal values. So when you run this command, you are creating secret directly from literal values without writing a YAML file and without doing base 64 yourself. So this part, create secret generic, tells Kubernetes you want a normal opaque secret. And this part, from literal DB password and then your password, this becomes the DB password key. And this part, from literal API key and then the API key, this becomes the API keys key. Kubernetes takes these raw values and base 64 encodes them automatically before storing them. If you check the final YAML with this command, you will see encoded values under the data section. Next, let's create secret from a file. So when you run this command, Kubernetes takes the content of the file and turns it into a secret value. So this part, like from file and dbpassword.txt, tells Kubernetes to read this particular file. And the file name dbpassword.txt becomes the key inside the secret. And the file content becomes the value, and Kubernetes base 64 encodes it automatically. So if dbpassword.txt contains your password, the secret YAML would end up with something like this. This is useful when your sensitive data already exists as files. You just pass them directly without editing the YAML. Now, moving on with our next topic, secret environment variable injection. Once you have a secret in Kubernetes, you often want your application to use it as an environment variable. This allows your app to read sensitive data securely without embedding it in code. So why use environment variable for secrets, right? It's because application can access sensitive information the same way they access normal environment variables. No need to store credentials in a container image. This also keeps Kubernetes native workflows clean and manageable. Now let's understand how to inject a secret as an environment variable. So inside your pod YAML, this part defines an environment variable inside the container, but instead of giving a plain value, it tells Kubernetes to pull that value from a secret. So this part, name, DB password or API key, this is the environment variable your containers will see. And the secret key reference tells Kubernetes the value comes from a secret. This name my secret is the secret object to read from. The key DB password or API key is the specific key inside that secret. Kubernetes fetches that encoded value from the secret, decodes it automatically, and injects it into the container as a normal environment variable. So inside the container, you end up with these decoded values. No base 64 anywhere inside the container. Kubernetes handles all decoding before the application sees it. Now let's understand how to inject all keys from a secret. So inside your pod YAML, this part tells Kubernetes to take every key inside the secret and turn each one into an environment variable inside the container. So this one, environment from, means you are loading environment variables in bulk. And secret reference says the source is a secret. Name my secret is the secret object Kubernetes should read. So if the secret contains DB password and API key, then the container automatically gets these decoded values. No need to define each one manually, and the environment from secret reference bring them all in at once. Now moving on with our next topic, mounting secrets as files. So some application expect sensitive informations as files instead of environment variables like certificates, .env files or SSH keys. Kubernetes lets you mount secrets as volumes. So each key becomes a file inside your container. Now, let's understand how to mount a secret as a volume. Inside your pod YAML, This part defines a volume, and instead of pulling data from a config map, it pulls it from a secret. So here the secret tells Kubernetes the volumes data comes from a secret, and the secret name my secret, this is the specific secret Kubernetes should read. Then this container section decides where inside the container that secret should show up. Just like with config maps, every key in the secret becomes a file inside etc secret. The file name is the key name, and the file content is the base 64 decoded secret value. So if the secret contains these encoded values, then inside the container you will see these decoded values. This is useful for application that read sensitive data from files instead of environment variables. Next, let's understand how to mount specific keys only. So inside your pod YAML, this part tells Kubernetes to mount only one specific key from the secret instead of the entire secret. So this secret name, my secret, this is the secret Kubernetes should read. And under items, the key DB password points to the exact entry inside that secret. The path dbpassword.txt is the file name it should appear as inside the container. Then in the container section, this part decides where that single file should show up. Here it's at etc secret. So Kubernetes takes only the DB password key from the secret and places its decoded value into etc secret dbpassword.txt. Only that particular key is mounted and nothing else, keeping the secret data minimal and focused inside the container. Moving on with our next topic, base 64 encoding or decoding. So Kubernetes stores secret values in base 64 format. So why base 64? Because Kubernetes requires it for YAML representation and safe transmission. Okay, so base 64 is not encryption. It only encodes data. Anyone with the access to the secret can decode it. Always combine base 64 with RBAC and encryption at rest for real security. Now let's see how to encode a value. So with this particular command, echo -n your password pipe and then base 64, this would encode a value. This -n avoids adding a new line at the end. And the output is what you put in data, like in a secret YAML. Now let's see how to decode a value. So with this command, echo your encoded password, then pipe base 64 decode. This gives you the decoded password. Moving on with our next topic, Immutable ConfigMaps. An Immutable ConfigMaps is a config map that cannot be modified after creation. So why immutable? This prevents accidental changes in production, ensures stability and consistency for running pods, improves performance because Kubernetes does not have to watch for changes on these config maps. So when do we use it? For critical production configuration, config maps that many pods depends on, or situations where you want to replace a config map instead of updating it in place. Now let's understand how to create a immutable config map. So in this config map YAML, this part tells Kubernetes that this config map is read only and cannot be changed after creation. And this immutable true locks the config map so no updates are allowed. If you try something like kubectl edit config map command, Kubernetes will block the change and return an error. Since this config map can't be modified, the only way to update its value is to create a new config map, update your pods or deployment to reference a new one. Since this config map cannot be modified, The only way to update its value is to create a new config map and update your pods or deployment to reference the new one. This is useful when you want to prevent accidental edits and ensure your configuration stays fixed once deployed. Now let's understand how to mount an immutable config map. So inside your pod YAML, this part tells Kubernetes to mount the config map called Immutable Config into the pod as a volume. Even though the config map is immutable, pods can still read it normally. Then this container section tells Kubernetes where the config map data should appear inside the container. Because the config map is immutable, the files under etc config will never change while the pod is running. Kubernetes guarantees that these mounted files remain stable and consistent. So the pod reads all keys from the config map as files at etc config, but the config map itself cannot be edited, giving you fixed, unchanging configuration inside the container. Moving on with our next topic, update strategy. In Kubernetes, config maps and secrets can change over time, but pods don't automatically reload their environment variables when this happens. So, if you change environment variables from config map or secrets, pod must be restarted to see the updates. If you change the volume mounts, files can update automatically, though there might be a slight delay. And if you change something in immutable config maps or secrets, this cannot be updated. You must create a new object and update the pod reference. So why this update strategy matters? Because you need a clear strategy to update configuration in running workload without downtime or misconfiguration. Now let's understand environment variable updates. So when a pod uses config map values like these, the environment variable is loaded only when the pod starts. So if you later update the config map, the running pod does not pick up the new value. It keeps using whatever value it loaded at startup. To make the pod see the updated value, you must restart the pod. For workloads like deployment, the simplest method is to use kubectl rollout restart deployment command. And after the restart, the pod starts fresh and loads the updated environment variable correctly. Now, let's understand volume mount updates. So when a pod mounts a config map as a volume, the config map keys shows up as files inside the etc config. Now, if you later update the config map, Kubernetes automatically refreshes the mounted files inside the running pod. This update normally happens within a few seconds, and pod sees the new file content without restarting. So, unlike the environment variables which require a pod restart, file-based mounts update on their own, making this method great for applications that read config files dynamically. Now, let's understand if we update immutable config map or secrets. So when a config map or secret is immutable, you can't edit it once it's created. Any attempt to modify it will fail. So the only valid approach is to replace it with a new version. So that strategy works like this. We will create a new object, then update your deployment or pod to point it to the new name. Kubernetes then rolls out new pods, and those pods load the updated configuration. So the pod now uses the new config map. Kubernetes then creates new pods with the updated configuration while the old one gets replaced. So that is it for today's video. Don't forget to check out another two playlists. The first one is related to Kubernetes scenario based questions, and the second playlist is related to failures and fixes in production environment. So do check them out. I'll mention the links in the description, and I'll also pin them to the comments. See you in the next one.